Suppose that x is a discrete random variable that takes on the values -7, -4, -1, 2, 5, 8, so it's going up by threes. If y is a good approximation for x, determine an expression in terms of x, the probability that y is between -5.5 and 3.5. So this is an interesting question. Usually we get an expression in terms of a discrete random variable that we'd like to calculate but are having trouble. And so we make the switch and get a probability in terms of our good approximation. But this question is sort of a flipping things around. Okay? Here we're given the probability in terms of the good approximation, and we'd like to get back in terms of x. You don't see this question as much because there's lots of possible answers, and let me show you why. As usual, when we're doing sort of this good approximation work, switching between discrete random variables and continuous random variables, you want to draw a number line, possibly a mock histogram. That tends to be my approach. Okay. So we'll draw just a pretend histogram. Remember, histograms aren't marked in this course, so we don't really need to do anything fancy here. Okay, we just have to have the main features. The rectangles all are adjacent to one another. Okay. This one starts where the last one stops. They're all centered above the values that x can be. There's our values for x. And the areas here represent probabilities. Right? That's what the histograms are really for. Now we could come along and we could imagine we've got this good approximation y that roughly goes ahead and behaves the same sort of way. I mean, personally, I'd probably make it dip a little bit more in the middle, but it's just a visual representation for us. Okay? So that's the density function for y. Okay? Now, what do we want? We want the area under y, right? We've got the probability. We go from -5.5 all the way up to 3.5. Now, where is that? Well, we might wish to start figuring out these sort of midway points. Okay. And it turns out -5.5, halfway between -7 and -4. Okay, 3.5 is here, 0.5 and -2.5. You could figure them all out, but we really just need the 2. So the probability we want is this area under the density function for y. So we've got that. That's a nice expression there. But we want to trade it for something in terms of x. Okay? Well, which boxes, which of the rectangles line up with these? Well, it doesn't take too long to see these pink boxes are exactly the ones we want. So we want to represent the values of x that are -4, -1, and 2. We don't want 5, we don't want -7. So one thing we could say is we want the values of x between -7 and 5 without any less than or equal signs. Okay, but that's not the only possible answer. Right? We could say, well, I'd like to start at -4, so we want to be greater than or equal to -4, but I never want to get bigger than 5. Or there's a lot of combinations. Because x is a discrete random variable, we can talk about less than or equals. You can't do that with continuous random variables, okay? But you absolutely can with discrete random variables. So you could say all the x's that are greater than or equal to -4 and less than or equal to 2. That also just expresses these 3. So this would more likely be sort of a multiple choice question, and you'd need to find a way to make your answer match one of the given ones, and it'd be one of these. Okay. But that's not the only thing. You could probably also get away with saying probability x is -4 or -1 or 2. Okay. It's wide open. Anything we can do to express the probability in terms of x of just these pink boxes, because they're the ones that correspond to the probability we are given in terms of y. So lots of answers for this one, but it's an interesting sort of role reversal, thinking things backwards style question.